Well, hello, Honors Physics, Chapter 2, Part 2. We're going to be talking about velocity, which is on page 43 of your textbook and beyond. Before I get carried away and forget to mention it, I've determined that our Chapter 2 test is going to be Tuesday, September 1st. And on Friday the 28th, we will have a review day, so we'll sit in class and review. I'll explain how these things are going to work in class. I just wanted to put that information out there, so please don't let me forget to comment about this in class. At any rate, to talk about velocity, I want to step back just slightly and do a quick review about displacement. I would like to do a quick review about displacement. So, remember that displacement is delta, that means change, and x means position, so displacement means change in position. Change in anything is always going to be the final minus the initial of that thing. So we have a final position and an initial position. The difference gives us our displacement. So to remember how this works, we are in one dimension, so we have a one-dimensional line, a one-dimensional mode of travel. We pick our 0 point. We assign our coordinates so we can visualize what we're doing. And let's do an example of displacement. Let's just say that we have an initial position of 3. So my initial position is there. Let's say that my final position is -1, and we want to determine the displacement. Well, my displacement is going to be my final position, which is -1, minus my initial position, which in this case is 3, which gives me a displacement of -4 units. Let's see if that makes sense. Well, I started here, and I went 1, 2, 3, 4 units that way. If you look at the graph, that way is positive, that way is negative. So when I went from 3 to -1, I was traveling in the negative direction. I was going this way. So 4 units. So that's a review of displacement. And in this case, we traveled in the negative direction. And remember, this negative sign is simply telling us the direction. We went to the left as opposed to the positive direction, which would be to the right, okay? And 4, that is the magnitude, that is the amount of units. A typical unit for us would be meters in length, okay? So what I want to comment on now is try to tie this idea of displacement into velocity. If I'm walking from here to here, I could do it really fast, or I could do it really slow. I could do it really slow, or I could do it really fast. Either way, it's going to take some amount of time. Making a displacement going from point A to point B always takes some amount of time. It can take a really long time, or it can take a really short time, but it always takes some amount of time. Velocity is the relationship between that displacement and the amount of time it takes you to do that displacement. Before I write the equation, I just want to say that velocity has the units of meters per second. We are traveling some number of meters in some number of seconds. So it's always going to be some number of meters per second, and it can be positive or negative depending on whether we're going to the right or to the left. All right, so remembering that, let's move on to what's called a position time graph. So let's just imagine that we plotted the position of somebody every second. So at time equals 0, they were at some location. At 1 second, we measured their position. At 2 seconds, we measured their position, so forth and so forth. And let's say that we plot it and we get that line. Okay? Now, if you remember from the old days, the equation of a line was y equals mx plus b. Y is going to be y. M is the slope of the line, steep or shallow. X is going to be the x value, the x-axis. And b is the y-intercept, which is right here. Now, I'm not actually plotting ym I'm not actually plotting y or x, I'm plotting position and time. So my variables are x and t. So what I want to do is rewrite this equation, except I want to rewrite it using our regular variables. Okay, I want to use the variables that I'm actually using. So the y variable would be x final. That equals the slope, which I'll just keep calling m. Then it's times the x value. Well, the x value in our case is t. And then plus the y-intercept. Well, the y-intercept is going to be the initial position. How did I know the y-intercept was the initial position? Well, when I'm right here at the y-intercept, that's going to be at time equals 0. At time equals 0, that's going to be the start, the initial place. So we have y is our x final on this grid. M is the slope still. X is t, that's my x-axis. B is my y-intercept, and that's my initial position. So I have y equals m x plus b. Okay? Now, if we play around with this equation a little bit, now I want to take the initial position and move it to the other side of the equation. So we get x final minus x initial. That would equal mt. Final minus initial, well, gosh, guys. Final minus initial looks an awful lot like this. So that's displacement. So that's displacement equals mt. And if we just keep going and we'll say displacement divided by t equals m, which to remind you is the slope. That's the slope. So the slope equals something, displacement over time. Well, what are the units of displacement over time? Well, displacement has the units of meters. Time has the units of seconds. So my slope has the units of meters per second. Well, hey. Velocity has the units of meters per second. So the slope of my position time graph, the slope of this line, it has the units of meters per second. That means the slope of this line on a position time graph is velocity. The slope of a position time graph is velocity. So my velocity is my displacement over time. And to remind you, near the beginning of this whole mumble-bumble, I mentioned that velocity was the relationship between your displacement and how much time you spent doing it, which is exactly what we have here. Velocity is displacement over time. I'm hoping that's pretty clear about velocity, and from this point I'm going to end the video and we'll start probably looking at working some problems at the whiteboard in class. So we'll talk to you.